Okay, good afternoon, all of you. In today's session of class 11 physics, we'll just quickly discuss what are the different types of errors. In our previous sessions, we have spoken about errors and we have had a look at a few numericals based on error and especially uh, the error due to the least count, and then what happens when you have combination of errors. So we have spoken about that, and there has been a few numericals on that. Now in today's session, actually we'll just make a quick list of what are the different types of errors. So the first one, I mean, some of these we have already spoken about earlier, so it's a kind of a recap. So least count error, like I told you, that it is associated with the resolution of the instrument. So for example, in your geometry box or in your pencil box, you have a scale. So that scale has got 0.1 centimeter least count. So this is the maximum error you can make whenever you are making any measurement with a geometry box scale. This is the maximum error you can make, 0.1 centimeter. Then you have vernier. Vernier is 0.01 centimeter. So in a vernier, this is the smallest unit. So this is the maximum error you can make, 0.01 centimeter. Then you have screw gauge. In a screw gauge, it is 0.001 centimeter. So this is the least count. That means this is the maximum error you can make in a screw gauge, 0.001 centimeter. So this is number one, least count error. Okay, now we come to mean like absolute error. That is number two, absolute error. So absolute error, what is the meaning of absolute error? See, what happens is that to maintain a higher accuracy of measurement, sometimes we take multiple readings. So we know that if you take multiple readings, you will get better accuracy of measurement. So suppose the readings you have taken are A1, A2, A3 up to AN. Okay. Suppose you have taken these readings A1, A2, A3 up to AN. So the arithmetic mean of all of them is A1 plus A2 plus A3 up to AN by N. So this will be the arithmetic mean of all the readings. Now what you have to do is that you have to find the absolute error for each of these readings. So how will you find that out? So each reading, suppose A1 or A2 or A3, you subtract the mean and take absolute value. Absolute value means don't, if you have a minus, you ignore the minus. So the modulus of delta A1 is modulus of A1 minus A mean. Modulus of delta A2 is modulus of A2 minus A mean. What does all this mean? It means that you are taking the absolute value of the difference of A1, A2, A3 from the mean. You are taking the absolute value, and so each of these is called the absolute error. Each one of these, this one, so you have so many absolute errors, and then whatever you got, you take the average of them. So this is called the mean absolute error. Okay, this is called the mean absolute error. So what I'm trying to say is that we are interested in getting higher accuracy of measurement. So we feel that to maintain higher accuracy, it's better you take multiple readings. So your readings are A1, A2, A3 like that up to AN. So the mean will be, you add everything by n, and then from each value like A1, A2, A3 etc. you subtract the mean and then you take the absolute value. So each of these is called the absolute error, and then if you take average of all of them, that is called the mean absolute error. So this is point number 2. Point number 3 is relative error. So the mean absolute error to the mean. So relative error is the mean absolute error divided by the mean. So this is called relative error. And percentage error is relative error into 100. So percentage error is relative error into 100, right? So these are the different types of error. Least count error, it is due to the resolution of the instrument. Absolute error, if you are taking multiple readings, then you must find the average and then absolute value of the difference of each reading from the average, and then the average of all of these is called the mean absolute error. Mean absolute error divided by the mean is called relative error, and relative error into 100 is called percentage error, right? So these are the different types of error. So based on this, I am giving you the homework now. Okay, the first question is, the time period of pendulum successive readings are 2.63 seconds, 2.56 seconds, 2.42 seconds, 2.71 seconds, 2.80 seconds. So these are the successive values of time period of a pendulum. So the question is, what is the absolute, relative and percentage error? So you are measuring time period of a pendulum, and these are the successive readings: 2.63, 2.56, 2.42, 2.71, 2.80. What is the absolute, relative and percentage error? This is question number 1. Okay, next question number 2. The length, breadth and height of a rectangular sheet 4.234 meter, 1.005 meter, 2.01 centimeter respectively. What is the area and volume? Correct to significant figures. This is question number 2. Question number 3. Mass of a box is 2.300 kg. Mass of a box is 2.300 kg and two gold pieces 20.15 gram, 20.17 gram are added. So the first question is what is the total mass of box and second question is what is the difference in mass of the pieces? Correct to significant figures, right? So these are the two questions. Mass of a box is 2.300 kg. There are two gold pieces 20.15 gram, 20.17 gram added. So first question is what is the total mass of the box? Second question is what is the difference in mass of the pieces? Correct to significant figures. So these are the three homework questions. And you can submit the homework anytime by 9 p.m. tomorrow, that is 9 p.m. Tuesday. So that will be all. I'll end the meeting. Bye all of you.